video. This is the continuation of the first video in which I've already discussed the first and the second case of Doppler effect. You can find the link below or just in the top right corner of this video. Just a quick introduction. We have a source and a listener. Whatever the source is emitting sound waves of actual frequency f, then the listener is hearing the frequency, that is the apparent frequency f dash of those sound waves. Moving on to some common terms, I've already explained these in my first video. Here I'm just going to rephrase this, that whenever we're talking about the source, we're talking about that person, that car, whoever it is, and those sound waves that is emitted by that source. So when the source moves, not only that person or that car moves with velocity a, but also the sound waves, they also move with velocity v. Whenever the listener is moving, only and only that velocity of listener is changing with velocity b. Another thing to note here is that whenever the source is moving, the velocity of those sound waves, they're also changing, and the velocity of source, that is basically a, is also changing. Now, we already discussed two cases for the change in frequency, that is for the Doppler effect. Now we're going to discuss the third case, that is when both the source and listener are moving. There is a very easy method in order to solve everything regarding the Doppler effect. The first, the second case, the third case, and even all the numericals. The easy method is to learn this formula, that is f dash apparent frequency is equals to bracket v plus minus b upon v plus minus a bracket close into f, that is the actual frequency. Now in terms of this plus minus, according to the situation we have, according to the formula we have to generate, the plus minus can vary. But if you can learn this formula, you can do everything regarding the Doppler effect. One thing to note in this formula, and you have to remember this, is let's just consider, right? We have a fraction, we have numerator upon denominator, right? You can do this in both of the ways. The first way is that you can consider that we have directly proportional or inversely proportional. Now we see that we have v and b, right? Plus minus doesn't matter. We have numerator and it is basically directly proportional to f dash, right? If I'm increasing the numerator, I'm increasing the apparent frequency. If I'm decreasing it, definitely the apparent frequency will also decrease. The second thing to note here is that the f dash, that is apparent frequency, it is inversely related to the denominator. So definitely if I'm increasing the denominator, so what will happen is that there will be a decrease in the apparent frequency. On the other hand, if I'm decreasing the denominator, definitely there will be an increase in the apparent frequency. You could do this way, or you could do it the other way. That is basically with a fraction, right? For example, we have 1 upon 2, right? Definitely the denominator is greater as compared to the numerator. So it is 0.5, right? However, if we have 2 upon 1, that is numerator is greater than as compared to the denominator, so that is 2, right? So whenever we have numerator is greater, so definitely the result is greater. And if I have the denominator is greater, the result is smaller as compared to when the numerator was greater, right? So you could do it both ways, but the easier one is to just consider that we have f dash, that is the apparent frequency, directly related to the numerator and inversely related to the denominator. So let's move on to the first part of the third case, when the source and listener are moving towards each other. You have to be practical in this, right? If I'm the listener and I'm moving towards that source, so definitely it will appear to me as the apparent frequency is increasing. And if I want to increase the apparent frequency, and I have b, that is the velocity of that listener in the numerator, so I'll just increase the numerator. And how I'll do that, I'll add an addition sign onto it. Similarly for the source, which is moving towards that listener, if an ambulance is moving towards me, so the sound or that frequency or the loudness of that horn or that ambulance, it will basically increase, right? And if I want to increase the apparent frequency from the denominator, which has a, that is the velocity of that source, so I'll just add a subtraction sign, which will decrease the denominator and in turn increase the apparent frequency. Thus we have this last formula, that is v plus b upon v minus a bracket close into f, that is the actual frequency. The second part of the third case, source and listener are moving away from each other. Let's see the numerator. We have b, that is the velocity of listener. Since the listener is moving away from the source. For example, if I'm moving away from an ambulance, so apparently to me, the frequency or that loudness, it will decrease, right? And since numerator and apparent frequency, they are directly related, so I will basically decrease the numerator in order to decrease apparent frequency. So I'll add a subtraction sign. And for the denominator, in which I have a, that is the velocity of that source. Since the apparent frequency, it will also decrease in that case, since it's moving away. So in order to decrease the apparent frequency, I will increase the denominator, that is v plus a, and in this case, the apparent frequency will decrease. The third part of the third case is when the source is moving towards the listener and the listener is moving away from the source. If the listener is moving away from the source, so just the same case, right? That is, apparent frequency is decreasing, and if I want to decrease that, so I will decrease the numerator as well, right? So we have a subtraction sign. If we have the source which is moving towards that listener, so definitely the apparent frequency, it will tend to increase. And if I want to increase that from the denominator, if I want to increase the apparent frequency from the denominator, so I will decrease the denominator. I'll add a subtraction sign onto it, which will in turn increase the apparent frequency. The last part of this third case is when the source is moving away from the listener and the listener is moving towards the source. When the listener is moving towards that source, so definitely the apparent frequency will increase. And if I want to increase the apparent frequency through the numerator, so I will increase the numerator as well. But as for the source, if it is moving away from the listener, so definitely the apparent frequency, it tends to decrease as well. And if I want to decrease the apparent frequency through the denominator, so I will increase the denominator since they're inversely related, so I'll add an addition sign. That's it for today. Thank you for watching. Do check out my other videos and don't forget to subscribe, like, and share. And if you have any questions, do comment down below.